Hi all, welcome to goclasses. In this lecture, we will study the properties which are satisfied by all lattices. Means every lattice will satisfy these properties. Okay. So we have already seen in the previous lectures some properties which are satisfied by all the lattices. So you can see these properties: commutative, associative, idempotence, absorption. So these four properties, these are satisfied by every lattice. Okay. So if any structure is lattice, then every lattice is going to satisfy these properties. Okay, so commutative, associative, idempotence property, and absorption property. We have already seen the proof in the previous lectures. Okay, so if you want to know the proof, like every lattice is going to satisfy these properties and what is the proof, then that we have already seen in the previous lectures. You can check it out. So remember, every lattice, okay, every lattice will satisfy these properties. So we know that LUB, GLB, they are commutative. So A or B is equal to A or B is equal to B or A and B is equal to B and A. Similarly, you can see they are associative. You can see this LUB, GLB, they are associative. Idempotence property, you can see A or A, that is A and A, that is A. Similarly, absorption property. So we have already seen the proof in the previous lectures. These properties, these four properties, these are satisfied by every lattice. Every lattice will satisfy these properties. But there are some more properties which are satisfied by all the lattices. See these properties, these three properties, these are also satisfied by every lattice. Okay, every lattice is going to satisfy these properties. So let's see the proof one by one. Okay, we will see the proof of each property one by one. We will see why these are satisfied by every lattice. But before seeing the proof, let's see some basic concepts. Let's do some revision. So we know that in any lattice, if you have any lattice, let's assume A comma B, these are two elements in this lattice, then two situations can happen. Either A comma B will be comparable or they will not be comparable. Okay, there are only two cases possible. Either A comma B, either they will be comparable. Okay, A comma B are either comparable or they are not comparable. Only two cases are possible, right? In any lattice, only two cases are possible, that either they will be comparable, either A comma B are comparable or they are not comparable. Only two cases are possible. A comma B are comparable, so one of them is related to another. It's so let's assume for a moment, just assume that A is related to B. Of course, you can assume B is related to A, that also you can assume, but you can see either A will be related to B or B will be related to A, but it will never happen that A is related to B and B is related to A. Between different elements, it will never happen. Okay, so I am just simply saying that if you have two different elements, let's assume A comma B are different elements. So now this is the simple point, that if they are comparable, then one of them is related to another. So just for a moment assume that A is related to B. Now you already know A is related to B. So then what is the LUB? You notice that this is your A or B and this is your A and B. So simple point. Now in this case too, what will happen? A comma B are not comparable. In this situation, what will happen? We already know in a lattice what happens. In a lattice, every two elements have LUB, GLB. So this A comma B, they will have LUB and they will also have GLB. So this is the point. So you can see this will happen. This will happen when A comma B are not comparable, and this will happen when A comma B are comparable. But in any situation, you can see whether A comma B are comparable or they are not comparable. In any situation, you can see one thing. What is that? See, here also you can see that A is related to A or B, right? A is related to A or B. This is related to A or B. Similarly, you can notice B is related to A or B. B is related to A or B. Why? Because they are same. Reflexive property. Okay, they are same. B comma A or B, they are same. So reflexive property. So I can say A is related to A or B. Similarly, B is related to A or B. So in this case, in the case one also you can see this is happening. Okay, and in the case 2 also this is happening. You can see A is related to A or B, and similarly you can notice that B is related to A or B. B is related to A or B. One more thing you can notice, that A and B is related to B. Okay, so you can simply this point also you can notice that A and B, that is related to B. This A and B, this is related to B. So A and B is related to B. Okay, also you can notice that A and B is related to A. A and B, that is related to A by reflexive property. A and B comma A, they are same. So A and B is related to A. Here also you can notice A and B is related to A. A and B, that is related to A. And you can notice that A and B, that is related to B. So what I am saying, what I am trying to say, I am saying that in any lattice, this always happen. In every lattice, this structure will happen. We have already seen this multiple times. In every lattice, this is going to happen. Okay, in every lattice, what is going to happen? You take any two elements, A comma B, these are any two elements, then this will happen. See, what this will happen, that A comma B, they will be related to A or B. Also, A and B will be related to A comma B. Okay, so in every lattice, what is going to happen? In every lattice, this is going to happen, that A will be related to A or B. Similarly, A and B will be related to A. A and B, that will be related to A. Similarly, you can notice A and B will be related to A or B by transitivity. So you can see A and B, that will be related to A or B by transitivity. So these are the points I am telling, that in every lattice this will happen. That for example, B is related to A or B, this will happen. Similarly, you can notice that A and B, that will be related to B, and you can notice A and B, that will be related to A or B by transitivity. So this is the simple point I am telling you, that whenever you see a lattice, then these properties will always be satisfied. If you take any lattice, every lattice, these properties will always be satisfied for all x. You take any lattice L, you take whatever lattice you want, you can take for every x comma y in this lattice. What is going to happen? These things are going to happen for every x comma y in this lattice. These things will happen, that x will be related to x or y. Similarly, x and y will be related to x. Similarly, x and y will be related to x or y. So these three properties will always happen. Okay, so this property. So whatever two elements you take in any lattice, you have lattice, then for all x comma y, whatever two elements you take, for all x comma y, you can see x will be related to x or y, x and y will be related to x and y will be related to x or y. And this you can easily remember, you can visualize this, you can keep this picture in mind. Okay, so just keep this picture in mind, that you can see A related to A or B. Similarly, A and B is related to A. Similarly, A and B is related to A or B. Similarly, you can see B is related to A or B. A and B is related to B. Okay, so this photo, you can keep this photo in your mind. I told you that in every lattice this will always happen. Whatever lattice you take, in every lattice, for all x comma y, these properties will be satisfied. So this is the definition of lattice. These properties we have already seen in the previous lectures also. Okay, so these are not new. There is nothing new here. We are just revising. Okay, so far whatever I told you, we have already seen in the previous lectures. So we have seen just the, I can say, revision of those concepts. Now let's see these properties one by one. I am telling that this property is satisfied by every lattice. Okay, what is this property? Notice what this property is saying. This property is saying that x and y that is related to, remember this symbol means related to. Okay, I told you that this symbol, this is the symbol for partial order relation. You already know that this is the symbol for partial order relation R. So you can simply call it R. Okay, I can say that what this property is saying, this property is saying that x and y is always related to x and x is always related to x or y. Similarly, x and y, similarly you can see x and y is related to y and y is related to x or y. We have already seen that this is correct. We have seen that this is correct. Okay, because we have already seen that for all x comma y this will happen. You have a lattice L, then this will happen. You take any x comma y in this lattice. Okay, for all x comma y, whatever x comma y you take, we already know this will always happen, that x will be related to x or y. Okay, x that will be related to x or y. Similarly, x and y will be related to x. So we have seen that x and y will definitely be related to x and x will be related to x or y. X will be related to x or y. Okay, so simple point. Similarly, x and y will be related to y and y will be related to x or y. Okay, so I can say x and y will be related to y and y will be related to x or y. So this is what I am saying. Okay, so this property is true for every lattice. So means whatever lattice you take, okay, any lattice you take, this will always happen. You take any lattice L, okay, every for I can say for all lattice L, you can take any lattice. For every lattice this will happen, that this property will always happen, that x and y is related to x is related to x or y. Okay, similarly this property, that x and y is related to y and y is related to x or y. Okay, so these two properties, they will always happen in every lattice, whatever lattice you take. Okay, so these are very easy if you visualize this. Just keep this diagram in mind. Okay, just keep visualize this. Okay, just do this visualization. So this is a simple property, we have seen the proof. Okay, the proof also we have seen. Now let's move on. Now let's see the second property. What about this second property? This second property has if and only if. So a lattice is given to you. So some lattice, this lattice is given to you, and this property B, this is having if and only if. So what this B is saying, this is saying that x is related to y, if and only if x and y is equal to x and y that is equal to x. Okay, so this is the property. Now let's prove this property. In this property there are two, there is if and only if. We have if and only if in this property. What it means? It means that if this happens, then this will happen. Okay, so we have to prove it. So this is the one direction we have to prove. The second direction we have to prove is this, that if this happens, then this happens. So we need to prove these two directions. Okay, so we need to prove the direction 1, direction 2. These two directions we have to prove. So let's prove them one by one. Let's prove the first direction. Okay, so let's prove this direction, that if this happens, then this will happen. So let's prove it. Okay, if x is related to y, then if x is related to y, then x and y will be related, will be equal to x. So let's prove this direction. So what is the proof? So let's prove it. See, this is actually very easy proof because they are comparable. If this happens, if x is related to y, see, if x is related to y, then what happens? This x, this is related to y. X is related to y. We already know that if x is related to y, then this y is same as x or y, and this x is same as x and y. So you can easily, that's it. This is your proof. That's it. So hence proved. So you can easily notice that if x is related to y, then what will happen? Then I can say that x and y will be equal to x. So this side we have proven. If x is related to y, then x and y will be equal to x. You can see x and y is equal to x. So this side is very easy to prove. Hence proved. Now let's see the another direction. So now we have to prove this another direction, that if this happens, then this will definitely happen. Okay, if x and y is equal to x, then x will be related to y. So how to prove it? So this is given to you. This is given to you that x and y is equal to x. So from here what you can say? One thing you already know, that in every lattice what happens? This you already know, that in every lattice what happens? This happens that this x and y will be related to y, and this y will be related to x or y. This happens in every lattice, correct? In every lattice this happens, that x and y is related to y, and this y is related to x or y. So this is always going to happen in every lattice. In every lattice this happens, I can say. In every lattice I can say that x and y will always be related to y. Okay, so this always happens in every lattice. We have seen this multiple times, that x and y is related to y. So very simple. Here also I can say that x and y, that will definitely be related to y. That will definitely be related to y, right? X and y, that will be related to y. But you can notice x and y is x. X and y is x. Okay, so this is already given to you, that x and y, that is x. This x and y, that is x, means this x and y, this is x. So it simply means that x is related to y, and this is what you needed to prove. Hence proved. See, very simple. This is a very simple proof. If you notice what we need to prove, see what we need to prove. We need to prove that if this happens, if x and y is equal to x, if x and y is equal to x, then from here we need to go Okay, if this happens, then we need to prove that x is related to y. This is what you need to prove. So what you can do, see, if x and y is equal to x, we already know that in every lattice, we already know this. Okay, we have seen this many times, that in every lattice, you know that x and y, that will always be related to x, that will always be related to y. Okay, x and y will always be related to y, x and y will be related to x also. Okay, so you just keep this photo in your mind, that x and y is related to y, and y is related to x or y. So very simple, this is what I am saying, that in every lattice x and y is related to y. Now this x and y, this is same as x, so this x and y, this is same as x. So from here what you got, you got that x is related to y. So this is what you got. Okay, so this is the proof. So we have seen this direction also. So we have proven this property, this property, this property, these two properties we have proven. Okay, now let's see the next property. The third property, let's see. Can you try this? Pause the video and try to prove it. Try to prove that this third property is true for every lattice. See, the third property is saying, this third property is saying that x is related to y if and only if x or y is equal to y. If and only if x or y is equal to y. This property. Okay, this is your statement C. Statement C is then saying that x is related to y. Remember, this symbol means related. So this simply means x is related to y. Okay, so we are saying that x is related to y if and only if x or y is equal to y. So in this we have, this is what we have to prove, but there is if and only if, means you have to prove two directions. The first direction you have to prove that if x is related to y, then this will happen. This is the one direction that you have to prove. Another direction that you have to prove is this direction. This direction also you have to prove. So two directions you need to prove. So let's see the first direction. Okay, so let's see this direction, that if this happens, then definitely this will happen. So let's prove it. And this is very simple direction. If x is related to y, if x is related to y, you already know that if x is related to y, then what is y? Then y is equal to x or y, and x is equal to x and y. So you can easily notice that. That's it. We got it. So we got this RHS. So remember, we have proven it. We have proven that if x is related to y, if x is related to y, then y is equal to x or y. Okay, so very simple. So this direction we have proven. Now let's see the another direction. Now we need to prove that if this happens, then definitely this will happen. Okay, so this direction we need to prove. So let's see the proof of this direction also. So here you can notice, if this happens, this is given to you that x or y is equal to y. Now you already know that in every lattice what happens. Now this point we already know that in every lattice what happens. In every lattice, y is always related to x or y. Y is always related to x or y. Similarly, x is also related to x or y. In every lattice, x is related to x or y. This always happens, we already know. Whatever lattice you take, in every lattice, these things will always happen. Whatever lattice you take, this x comma y, they will be related to x or y. Also, this x and y will be related to x and y will be related to y. So this point we already know. In every lattice, okay, this will always happen. In every lattice, x will be related to x or y. This always happens. So here I can say that in every lattice, x is related to x or y. X or y is y. X or y is y. So this x or y, that is y. So I can say that x is related to y. And this is what you wanted to prove. So hence proved. So very simple. I hope this point is clear. Remember what we have done. This is what we have done, that if x or y, if that is equal to y, then we need to prove that x is related to y. This is what we need to prove. This is what we need to do. We need to prove that x is related to y. So what you can do, from here, you can easily notice that in every lattice, x is related to x or y. This happens in every lattice. Whatever lattice you take, in every lattice, it will always happen. It will always happen that x is related to x or y. Now, it is given that x or y is equal to y. X or y is equal to y. That simply means that x is related to y. This is what we wanted to prove. So hence proved. So we have seen this direction also. So we have seen the proof of this statement, this statement, this statement. These three properties we have seen. So ultimately, if you notice in these three properties, one concept that is very useful that we are applying again and again repeatedly. So this is the final concept. This we have applied this many times, that in every lattice, just remember this concept and you can solve many questions you can solve. Okay, many proofs you can do. Remember, in every lattice this will always happen. If you take any lattice, L, let's assume that x comma y belonging to L, so these are elements. Now this will always happen that x, y, because this is a lattice, so every two elements will have GLB, LUB, so they will have this x comma y, they will have LUB, also they will have GLB. So this is the point. Now I am saying that in every lattice what is going to happen, you can see that x will be related to x or y. Okay, similarly y is related to x or y. Okay, y is related to x or y. Similarly, you can notice x and y is related to x. This x and y, this is related to x. Similarly, x and y is related to y. X and y is related to y. Also, x and y is transitively related to x or y. This x and y, this is transitively related to x or y. So very simple. In every lattice these things will happen. So you can notice this concept we have applied in the proof of these three properties. In this lecture we have seen three properties. For each of them this simple concept we are using. Okay, so this is very useful concept in many questions. Remember, whatever x comma y you take, any x comma y, whatever x comma y you take, I can say for all x comma y, this will always happen that x is related to x or y is related to x or y, x and y related to x and y related to y, x and y related to x or y. This diagram you can remember. This diagram you can keep in your mind. Okay, so very easily you can do. So we have seen three properties that are satisfied by every lattice and we have seen their proof also.